Hey everyone, welcome to this really cool walkthrough where we are blending Microsoft Purview DLP, Power Automate, and a bit of AI magic to solve a real world security challenge. Now, initially, I was just going to write a simple blog post showing how you can use the DLP action, which says trigger Power Automate flow from DLP policies, and the possibilities of how you handle DLP incidents with the Power Automate flow are kind of endless and yeah, that alone would have been pretty awesome, right? But then I thought, what if we took this further? What if we applied this to a real problem, one that a former customer of mine was seriously struggling with? So that's when this idea clicked. So let's build a hands-on solution where we automatically detect source code being uploaded to a SharePoint site that has external sharing enabled, and we quarantine that file and then analyze it using AI, all of it in near real time. So in this session, I'll show you the end-to-end flow, walk you through the architecture, the Power Automate steps, and even how you can make life a lot easier for your SOC analysts who are often drowning in alert fatigue. So buckle up. This is going to be a fun, practical dive into what happens when information protection, automation, and AI come together to solve a real problem. All right. Let's start with the challenge. What's one of the most difficult things for SOC analysts when it comes to DLP alerts? So imagine you're a security analyst and you get this notification. File containing source code uploaded to SharePoint that has external sharing enabled. Sounds scary, right? But there's no context, no clue what language the code is written in, no idea if it's just a harmless internal script or something serious like an exposed customer credential. So you're stuck, right? You have to dig into the file manually, figure out what's going on, assess the risk, and then respond, all while your inbox is lighting up with 20 other alerts. It is time consuming. Plus, there is no built in intelligence at all. If you look at the DLP incident, it only talks about where the file is, what is it, which sensitive information type, or which specific trainable classifier, or whichever classifier you are targeting is being detected. There is absolutely no intelligence. Everything looks like a potential fire, but you're not sure which one to put out first. That's the real problem. There's just too much noise, but not enough signal. So here is where it gets interesting. What if the alert did not just say source code found, but instead told you that the alert detected a Python script? It called Azure APIs, or the script is calling Azure APIs with some hard coded access tokens, and the risk is high because there is some credential exposure, right? That's actionable. Now that's intelligence, and we're going to do that using a combination of Purview DLP, Power Automate, and some Azure OpenAI GPT. Now, so we detect source code in externally shared SharePoint sites. We send those files to GPT for analysis, and then we extract the details of that analysis. We assess the risk. We quarantine the file, and then we update that information back as metadata on top of that particular file. So here is how this works in detail. A user uploads a file to a SharePoint site that has external sharing enabled. Now that file happens to contain source code. Our DLP policy, which uses a trainable classifier, again the first instance where AI is being used in the solution, is the trainable classifier that detects source code. It flags it instantly, and instead of just blocking or just alerting, what we are doing is we've also configured the DLP action to trigger a Power Automate flow. Now that flow grabs the file's metadata, reads the binary content of the file, and then sends it to an Azure function to convert it into some readable text, and then calls GPT. Now, the content that we extract from the file using the action that we use in Power Automate gives us the content in base 64 format, which is the binary format, and then I've written a specific Azure function that will convert that into human readable string, and that string can then be passed on to GPT for analysis. Now, GPT analyzes the code and gives us back all the good stuff, right? What is the language used? What is the risk level? What is the purpose of that particular code? And based on that, we take action. We quarantine the file. We update the metadata with those GPT insights. And it's just like building a smart security analyst inside that flow itself, right? Okay. Now, how does it help? So for SOC teams, this changes the game, right? Instead of generic DLP alerts, they now get rich contextual incidents, They don't need to dig through files. They get a snapshot of the risk instantly. There's less manual triage, faster decision making, and more time spent on actual threat response. We are able to move fast, and files are being analyzed before violations can actually escalate. So the file is quarantined immediately. And if the AI deems it safe, it's going to say that, right? And then humans can, of course, go and quickly verify it and then restore it. So we are not just alerting, we are containing, we are controlling, and then we are enabling responsible recovery, all with the help of actionable automated intelligence. So let us take a look at the solution. Okay. So what we're going to look at first is the DLP policy itself. Wow, sure. So the DLP policy I have here is called quarantine sensitive files in external workspaces. I'll just move next quickly, and I'm not going to assign any admin units for the purpose of this demo. Just I've chosen some locations, two SharePoint sites and a OneDrive account to target this policy to. And let's have a look at the rule that I've set up for this DLP policy. So if you see what we're trying to detect, if there is any specific file that gets uploaded in that SharePoint site, then we're trying to look for source code in those files using the trainable classifier called as source code. And the action that we are taking here is to trigger a Power Automate flow. So the typical action of either blocking the file is not applied here. Instead, we trigger a Power Automate flow. And the flow that I'm using is the DLP quarantine file flow. So let's go and look at what the flow looks like. And here is the flow that I've created. So this particular flow is triggered when an item violates a DLP policy, which is the policy that we've configured. And what it does is it sends an HTTP request to SharePoint. So this HTTP request is to get the sensitivity label that has been applied on that site. Now, I have two sensitivity labels configured in the tenant. One is internal workspaces and the other is external workspaces, indicating what is the type of sharing settings that has been applied to that site. And what we are interested in is if the file has been uploaded to a SharePoint site that has the label external workspaces. So then comes the condition where I say that if the sensitivity label applied on the site is equal to external workspace, only then we want to go ahead. So what we then do is we get the file content using the path of that particular file. And as I said, the output of this particular action is a base 64 binary content of that particular file. So I have written a Azure function here. And I'm just going to quickly show you the Azure function. It's a small function to extract the string or readable string from base 64. So this is the Azure function that has been published, and this is being called here. The output, as I said, is the human readable string. And this particular string, which is nothing but the source code that has been detected in that file, is then passed on to GPT for analysis. So what is the prompt that I've written here? Is I'm asking the AI model to go and analyze the source code and return some specific values. And those values are what kind of language is the source code in, what is the purpose of that specific source code, what are the API endpoints, if there are any in that particular source code, any hard coded tokens or secrets, what is the risk level based on the analysis of the AI, what is the risk level, whether it's low, medium, or high, and what is the reason for that risk level. So this is what the prompt looks like. Analyze the document, and if the document contains any source code, then extract it. You are a code security specialist. Analyze this source code, and the input of this particular prompt is the source code that I got from the previous step. So that's it. It's very basic. And here we are using the GPT-4o mini model. You have a couple of choices here. You can also use the standard GPT-4o model, but for this particular demo, I think this was sufficient. So I'm just using this one, and I'll cancel this. And then what we do is we move the file to quarantine because analysis of that particular incident might take some time. It is best to quarantine the file. I'm just going to move it to some random site within a documents folder. And then I update the properties of the file. So I have a couple of columns already created in that particular site. and I'll be updating those columns. So this is what this particular step looks like. What we will do is we'll look at everything together in action. So let's see what happens when you upload files in those specific sites. So here I have this particular site where I'm going to upload some source code. So I have some sample files that I had already created for the purpose of this demo. I'm just going to upload these files. As you can see, there are a couple of, most of them are Word files, but there is one file which is .cs as well, which is a C# script. So I've uploaded them. What we will have to do is wait for the DLP to trigger. And when the DLP triggers, I think it's already started triggering for one of the files. It should trigger for all of them because all of them are or should match the trainable classifier. Now, if you see the folder suddenly empty, there's no file, all of them have been quarantined, and they have then moved to this particular site where all of these files have now got a risk level, the language the particular code is written in, the purpose of the code, the API endpoints, if it has found any in that particular code, any hard coded tokens, this is especially useful, and the reason for the risk level. So you see that there are a couple of files with high risk level, there is a file with medium risk level, there is a file with low risk level, and there's a file again with the high risk level. So if you see the one that is with the low risk level, it is just a script for a website. So the purpose is the React component for a website related to information governance and compliance. Now, the reason for the risk level is the code does not contain any sensitive information or high risk operations. Similarly, let's analyze what happened to a file which was written in C#. The purpose of that particular code, what is the code actually trying to do? Dynamically load and execute a user defined assembly and called a API to fetch weather data. Now, what is the reason for this risk level? So that the code dynamically loads assemblies and executes methods which can lead to code injection vulnerabilities. Additionally, it contains a hard-coded API key which poses a security risk if exposed. So this particular piece of code had some hard-coded secrets or token, and that's why it was flagged as high. Similarly, there's another one with Medium, and what it does is it analyzes log files for errors, warnings, and request times and user activity. Now, there are no API endpoints, there are no hard coded tokens, but still, this particular piece of code or this particular file was flagged as Medium because the code processes user and activity logs, which may expose sensitive information if not handled properly. So, what is happening here is it is not just looking at the signals that are present here, which is the hard-coded tokens or what kinds of API endpoints are being called, but then it is trying to analyze the code and see if the code itself is doing something malicious, right? So that's how we are using this particular solution. What I'll also do is I'll also open up the flow and show you one successful run on what the outputs of each step are, so that it becomes pretty easy to analyze. So the first one is we of course call the HTTP request, or we make that HTTP request to SharePoint, and the output is the display name of the sensitivity label and the ID of the sensitivity label, this external workspace. And what we then do is in this specific condition here, we try to compare it. And what we then get is the file content. So here, if you see the output, we get the content as binary, right? This is the content here that you can see. So then we are making the call to the Azure function that I've written. This is the Azure function. And of course, in a production scenario, you would execute it or you would call it with a more secure approach. Here, I'm using a function key, which is definitely not recommended. So you would use a more secure approach, like either using a managed identity um, and then calling the Azure function. So the input it takes is the base 64 content and the file name, and the output is the code that has been written, the entire code or whatever text is present in that file. Now that file is then sent to this GPT here. And if you see the output here, let me go back and show you the raw output. Yes. And this is where it gets interesting. What we get is a JSON format of all the data we requested for the language, the purpose, the risk level, and everything. And if you see, it also gives us a structured output. What is the language? What is the purpose? What is the code trying to do? If it found any APIs or any hard-coded tokens or strings, what is the risk level, and what is the reason behind that particular risk level that it is suggesting, right? So we get all of that information. We of course move the file and then we update the file properties with all the data. So if you see the output here again, we have updated this particular file with all the important information. Okay, that's about it. That's how you would use this particular solution. Of course, you can extend it based on your needs, but this is a very basic example of how you can ensure that your DLP incidents can be easily analyzed, and you can leverage the power of AI within Power Automate to ensure that your the driving process is much faster. Also, you could also create a custom Copilot agent for this purpose, and the agent could be, let's say, Code Analyzer can be the agent name, and it can do the same thing. So that's also fine. But I used the action within AI Builder to get to this particular solution. Okay, that's it from me for today. Thank you everyone for watching this. Bye.